So I wanted to put together this video to show some of the things that I've learned about the importance of processing RGB data and luminance data and combining it. And I learned a lot of stuff, as there's great video on the internet, as most of you have probably seen. If you haven't, you'll see it eventually. But one thing I did not too distant past is discover Adam Block and his tutorials. And I'm not endorsed by Adam, or I'm not paid by Adam to say this or do this, but he does some fantastic stuff with PixInsight. And what I really like about his approach is he gives you real world examples, but he also breaks down tools and techniques to help you really understand what's happening. And to me, that was very powerful in understanding, what I was manipulating when using a particular tool or technique or process versus just, trying to get some results. And one of the things that he did that really helped me understand better how to achieve detail and achieve color, again, by separating color from luminance, was powerful. And I want to show that here. And again, it doesn't deal with real astronomical data. It deals with real simple images. Again, I'll show you the approach, and it's very simple to achieve. And hopefully you can see some of the ideas, again, behind it about what you're dealing with. So what he does, or I shouldn't say what he does, because again, I'm giving him credit. I don't want to try to, take credit for what he did, but we'll start with two images. So I've got basically all the processes, tools, and PixInsight that I need right here to achieve an example. So let's start with creating two new images, and one's going to be grayscale, and it's going to be my luminance. So I want to just create a black image and in grayscale, and this is the pixel size of my camera, so I'm just going to use that as the example. And then I'm going to create an RGB image. Again, this is not the real image, this is just a placeholder. So I'm going to create it in color space. Again, I want it to be black. All right, so I don't need this anymore. And so let's start with the luminance image. So what this is going to be a gradient, horizontal gradient, where the extreme left-hand side is going to be black and the extreme right-hand side is going to be white. So to do that, again, I'm going to use pixel math. And let's see, set this. So single expression, and all I want to do is insert the value of the position from left to right. So that'll go from 0 to 1 and create the appropriate gradient. And again, I'm just going to keep all this stuff the same and replace the target image. So, all right, so there's a gradient, and this will represent my luminance, right? So this is every possible value from black to white that could be in a luminance image. So let's set that aside for now. Okay, now I want to create the color image. And again, this is straight out of Adam's example. So what we're effectively going to do is use some very simple pixel math functions to create 3 horizontal bands of color, one red, one green, one blue. So here's very simply some variables that kind of define the first band, if you will, that's from 0 to 300. And I think I have to change this width and height, so bear with me. And get this out of here. So I changed the width on this since my last run of this. So my width is now 3354. So that defines that variable, and then I'm going to have each band be 200 high. All right. So the first one will basically say if it's in the rectangle defined by y and 0, which is 0 to 300, then and we're within the width and the height, which is anywhere in the height of 200 to that, then draw a value of 1, otherwise 0, right? And then the same thing for green and blue, except y is being offset. So we're moving it down by 300 pixels to draw the green, and then we're moving it down 600 pixels to draw the blue. Okay, so let's do that and see what happens. And I can get rid of this, and we're just replacing the target. So as we can see, there we go. Okay, so that's great, but it's not what we want, because this doesn't represent this is not a good example of an astronomical image. The background is not pure black, and the colors are really never pure red, green, and blue. So we're going to change this a little bit, and again, to make it more realistic. So instead of having a true something that's pure red or pure green or pure blue, we're going to scale it a little bit. So we're going to do 0.1. And again, this is not even probably realistic, but it's certainly closer, right? And then the other thing we're going to do is we're never having a pure background. So let's get something more realistic here too. So 0.2, and we'll do this 0.2, 0.02, sorry, and 0.02. All right, so let's apply that. Okay, so this again looks more realistic, and again, this is a linear image, and if I were to go nonlinear, that's what it would look like. Okay, so let's we don't need this anymore. All right, so now I've got a luminance layer and a linear RGB image. So first thing I want to do is take this nonlinear. So I'm just going to do this the standard stretch. Well, not standard, certainly a very standard way is to again, let's do this. Whoops, let me do this. All right, so let's stretch by doing this. All right, so now my image, my RGB image is nonlinear, right? So now the next step would be to overlay the luminance on top of the RGB, right? So let's do that. So to do that, we use LRGB combination. So here's my luminance. So I want to, let's do reset. So I would do, uncheck all of these, and then I would use luminance as the L layer, and now we can just apply it. So all right, so there's what we achieve and what you can see, and again, you may have to do this on your own to really see the effects of this, as I'm sure the video doesn't really show it as it truly exists in your world, your monitor, in the way you see it. But what I can say for sure is, if I look again across the luminance gradient, each color really has its best kind of appearance and saturation level in different areas. So red for me is somewhere in this area. It looks really, really good. Green is kind of, I would say, more in this area, and blue is down here in this area. So as you can see, from a luminance perspective, the higher the signal goes, the more washed out it goes, it gets. And one of the things that also kind of was this was an eye-opener to me, right, to understand kind of how things work. But one of the things that's important, I think, that again Adam talks about is there is a magical number that, and again, I don't know if magical is the right word, but around 8 is kind of that top threshold of, if you're processing your luminance layer, that 8 or less, a number under 8 is ideal for, getting a good color representation. Again, good is all open to interpretation, but certainly anything over 8 in the signal of the luminance layer is not really where you want to be. Okay. So to me, this was a great way to understand kind of what's happening here. And I want to take it a little bit further and show some things that I know have been discussed on various forums and some of the forums I'm on. And again, this concept of processing luminance as a way to bring out detail, and processing color separately to get color that you want, and how that differs. So let's go back to our original version of the RGB. Right? So we've got, let me get this out of the way so it doesn't look like my RGB is actually a gradient. Okay. All right. So again, this is clearly not a typical representation of an astronomical image. So let's again try to make it a little more realistic. So we've got a background level that's, again, closer to what's reality, but it's not. But it's better than pure black, and we don't have pure red, green, and blue going on here either as well. So one of the ways that I would say to prove or show that it's all in the luminance layer, and it's from a detail perspective, it's not necessarily in the color layer, is to do something like this. All right, so let's create a preview, and again, you could do this on the full image too. I think the effect is better at a higher resolution, 1:1 versus 1:3. All right, so let's introduce some noise. So if we take our noise generator, and let's see, I'll just start with the default and see what that does. All right, so that's not too bad. We could step it up a little bit, maybe just even. Oops, sorry, I forgot I was in a preview. Let's go back here. I don't have to undo it. Let's just say, let's double it. Let's see what happens. All right, so that's pretty noisy. So if I do that, here's another actually trick that I discovered again through looking at Adam's videos that I didn't realize, and maybe you guys do. So if I want to do more to this preview, I can store that operation. So now whatever I apply next won't undo or just eliminate that noise reduction. So that's kind of cool too. All right, so now I want to just do an LRGB combination and see what happens. All right, so again, there's some noise, but it's still not bad. Again, you can kind of see if I do, let's see. All right, so it kind of hides the noise. I still get some good color, so that's kind of cool. So now if I do, and actually I think I'm gonna have to pull this out. I don't think I can again store it. Yeah. So you can only store at most one operation. So at most you could do 2 operations on a preview. So what I'm going to do is I'm just going to back this out as an image. That way I can actually work on it independently. So now I've got the preview of, oops, I didn't want to go that big, sorry. All right, I want 1:1, there we go. All right, so I've got a noisy RGB, and I want to deal with this chrominance noise in some way. So again, I'm going to create another duplicate here. So and I'm going to create a third. Oops. Okay, don't need that anymore. Let's get rid of that. We'll keep this guy over here. All right, so we've got 3 duplicates, all of the same color image, and they're all somewhat noisy. All right, so if I just take this one, apply luminance. Whoops. try again. Oh, yes, incompatible to image range. Duh, Brad. All right, so let me get my luminance. Let me get my RGB, which hopefully still has that preview. Good. So now I can do this. Just copy this preview over there. Take this preview out. Now we can close these and replace this over here. So now I put the same image. Now we're apples and apples. Okay, so now if I do this, all right, so this should work. Okay, so there's my just overlaid luminance. So let's see what happens if I apply this chrominance noise reduction. All right, so if we do appropriate zoom, and actually let me stretch this some more so we can kind of see it. Compare that, stretch it. What's that not stretching? Oh, I'm on the same image, sorry. All right, so you can see that it's reduced it a little bit. It's, again, you may not see it on your screen with the video, but if you were doing this in real life, you would see that there's slightly less noise here using that. So now the other thing that I also do, and you could do, is to add some convolution to this. Let's see, that didn't come up. Let me do that again. There we go. All right, so add some convolution to it. So I'm going to change the shape a lot. And I think I'm even going to change this. All right, so if I do some blurring, all right, so now I've got a blurred image. And now if I overlay it, okay, and we stretch it, and let's look at this. All right, so there you can see I've pretty much gotten rid of all the noise. Now, again, you can see there's some blurry detail here, so I've probably done way more convolution than I need to, but you can see how convolution is a good example of eliminating chrominance noise reduction, all right? So the question is, what's the right level? And again, it's all trial and error, right? So if I do, oops, I think I did something. Yeah, there we go. Give this back to, all right. So if I just did standard, no parameter change convolution on this, all right, so again, that's fairly blurry. So let's add this again. Let's overstretch it and let's look at it. So again, the blur isn't so dramatic on the contrast between the gray and the green. Again, this is extreme examples, right? So it wouldn't necessarily be as detrimental in your astronomical image, but it gives you kind of the insight. So we've overstretched it. Let's compare. All right. So as we go across, most noise, less noise, chrominance noise, that is. Again, theoretically, my luminance layer is noise-free, right? So proof that there's chrominance noise and how you can eliminate it or reduce it by doing these techniques, and proof that the more that you can manage a really good signal to noise ratio in your luminance image and enhance contrast and detail, the more the color is going to pop and be vibrant. And again, keeping in mind keeping in mind that this, let me change this back to L luminance and apply it here. Keeping in mind that there is a sweet spot, if you will, for each color given the luminance signal, as well as a level that you want to make sure that as you're processing your images to achieve the really best colors to stay below that 0.8. And there are some other techniques that he shows, so that again I think are powerful from a color perspective, and I'll show a couple here. So let's take the same image, let's undo this. Again, let's create a duplicate. of this. And so we can compare and contrast. So I can get rid of this preview. I don't really need it for this example. Yes. All right, and then I'm going to close these. So I'm kind of done with these. So that was showing how you can achieve a really good end result, even if the RGB image looks a little bit absurd or even again blurry. And that the luminance layer is where it's all at from bringing out the detail. So color, in that respect, you can think about how you process color differently and not worry about detail and bringing that out. It's more about, am I getting the color palette that I want? So again, if we have the same image and we look at two different examples, so again, we'll say this is our automatically stretched nonlinear version of our background of our color image with the luminance channel applied. And again, what we see here is, again, red's really nice here, green's really nice here, and blue happens to be really nice down here in this layer, right? So what if we change the contrast between this and the colors? So what we can do is let's take our screen stretch here and let's click on this. So we're here and let's make sure we're stretched and let's do this. Oops, what's happening here? All right, so I'm gonna bring the background down and I'm gonna even brighten that a little bit, bring it down a bit more, right? So I'm really changing a lot of contrast here, right? So let's let's make that permanent on that image. Okay. All right, so now I've got a higher contrast image for color and background. So now let's apply this luminance channel. See what happens. Okay. So now if I overlay these, let's try this and see if this works. Let me just do this here. Let's get this guy up here. Let's expand it a little bit. Expand it there. Let's see. If I flash these two. All right. So there's my normal one again. So I'm going to put my cursor where the red is really nice in this image. And then if I bring up the other one, wow, it's slid up here and green has slid up and blue has slid up. So there's, again, changing the color image contrast has changed where my colors pop within the luminance channel, right? So again, the luminance has stayed the same. It's just a consistent gradient. So I've achieved a red color in a higher red color in a higher signal in my luminance than I would in the other one, right? So that's an interesting example. And there's another example that he does as well, which I think is interesting. And again, this doesn't always work, but it's something that you can certainly entertain either in your process or as a tool in your mind about, what's happening behind the scenes, given this very simple example using nothing but a gradient and some consistent color, about how the math is working, right? Because that's really all what it comes down to at the end of the day. It's math, it's numbers and math. So we've got we've got a screen stretched version. We've got a screen stretched version with high contrast, or we've changed the contrast by basically clipping the background and increasing the midtones. So let's do another one. And again, I've not tried this, so this is kind of going to be an experiment here. But if I take this guy and I go back to our original image and I'm going to unstretch it, I'm going to duplicate it. So let's do, let me redo this. So that's the stretch and that's the luminance layer. So I'm going to put that off to the side. Okay, so there's that guy. I'm going to rename this. So this is RGB contrast So that's when we changed, and this is just basically RGB STF. So let's name this. Rename this to RGB, and we're going to use a arc sign stretch on this. And again, I've used arc sign stretch a couple of times in the past. I find it for galaxy work actually not bad. For narrowband nebula stuff, I haven't really played with it much or had much success, but it's certainly something you should play with. All right, so we've got a non-stretched image here. I want to go to intensity transformations and bring up arc sign stretch. And let me reset this. And again, this is a funky kind of tool, but I'm just going to try something here and go like really high, like 90, and see what happens. All right, so that's pretty grand. Let's just see what happens. All right, so there's my overly stretched image. And again, this could serve as an example of if you were doing this, and we'll see how this comes out as we do the luminance layer overlay, but as you're processing, you might say to yourself, oh my God, that's horrible. That's not right, right? But sometimes, again, the RGB may look horrible if you're just looking at it. And then until we add the luminance to it to see how it blends, then that's really where you make the call. So let's see what happens here. And again, this may be hideous because again, I may have completely overstretched it, but we'll find out. So let's see. Okay, interesting, right? So let's do our blend again. Let's do so here's our arc sign stretch. Where's our original contrast stretch? So let's go like this. All right, so again, red right there. If I show the other one, now I've got it, again, it's a little further up the scale. Blue's kind of still there and green's kind of moved, but it's definitely, I mean, you can, again, my guess is it doesn't come out on the screen, but everything from a color perspective is not only shifting, but what I noticed interestingly enough about this one is even at the higher end where that 0.8 is, these colors are actually better across the board, which is, again, very interesting on how the arc sign stretch performs with respect to that. So just as, again, as a comparison, if I go back to the, I'm sorry, I was comparing it to the contrasty one, but that was still interesting in that difference. So let's look at it compared to STF. Again, we might see a even better or more dramatic one because, again, the contrast one I've pushed a lot. So what's this look like compared to the just standard stretch? So there's the standard stretch. Yeah, I mean, way better color pop. Honestly, across the whole kind of midtones area. So arc sign stretch could be an interesting tool. Certainly red and green seem to be better all across this area. I mean, it's higher here in the red, but I see clearly more color contrast up here in the arc sign stretch versus the STF version. And then same thing with green. It's really up in here. Blue is, so again, with the STF, it's kind of down here. With that, it gets better up in this area. And even here, there's a difference. So again, arc sign stretch, interesting tool. If I did, let's see, yeah. I was thinking if you did manual stretch with histogram, what you could achieve, but again, theoretically, STF is the right one to do. So this is, to me, it really opened my eyes to what's happening again versus, staring at a beautiful nebula and trying to get something that you wanted and not really maybe getting there. This to me broke it down into the simplest terms about, what the luminance is, right? Theoretically, and this gradient again puts it in a very simple terms is no matter where I am in my luminance layer, luminance channel. If I've got something close to 0, how it behaves color-wise. If I've got something close to 1, how it behaves color-wise. And then, again, the differences in what I can do at the RGB layer, not only from a noise perspective and not worry about and trying to minimize, and what I need to really be concerned about is chrominance noise and how to minimize that, either by capturing enough data to minimize it, or using something like convolution to basically blur it out before I combine the luminance layer. And then understanding about what techniques I can focus on to get my color to pop in my luminance layer, about changing contrast or using a different stretch approach, versus going right to the saturation curve or the color saturation tool to achieve it. So hopefully this video helps, and it helped me. Again, I don't get paid by Adam Block, or I'm not a spokesperson for him, but I got to say, his videos do a fantastic job at not only showing you how to use PixInsight and showing you real world examples, but he takes a lot of time to explain what a tool is doing, such that you really understand before you use it. Okay, if I do this, I know what it's trying to do, and therefore, do you get the desired result or not? I can't express that enough, and he does that a lot in a lot of ways. And this is just one example that he did to show how not only does LRGB combination work, but just how, again, overlaying luminance onto an RGB image can be thought about so that you can achieve an end result that you want and that looks good. So again, thanks for watching, and hope this helped.